Hello there, this is Lee Noring. In this video I'm going to illustrate the simulated drawing of a logo which is being designed for a custom sign. This particular logo represents the letter O in the logo, and it is being designed to be a 3D carving which will end up looking similar to what you see. See, right here we have the roughing toolpath, and over here we have the vector lines, and here you see where the 3D object is designed, and I've set this slightly indented line to be the border of the rough cut. Now the bit being chosen is a 1/4 inch ball nose with a 50% overstep, or a 0.125 inches. In this particular case I got a maximum feed rate of 10 inches and a plunge rate of 5 inches a minute. With this vector selected, I hit calculate. Here you see that this toolpath is for the 3D image. It's listed number 50 as a way to display them in the file directory in order. It says 3D roughing, which tells you what it is, and this part right here, 0.25 ball at 50%, is the bit being used in the overlap design. Now we calculate. It'll take a minute or two to design the toolpath. Here you see a simulation of the toolpath over the simulated 3D image. We do a preview of the rough cut. Here you can see the bit outline and how it's will cut into the board in simulation. You can see with a 50% overlap, it takes out quite a bit of wood pretty fast, but it's not something you'd want to end up with. So now let's go right here to the 3D item 55 finish with a 1.25 diameter with a 15% overlap, or a 0.0187 inch. Here we're not taking away a lot of wood with a small bit, so I'm pushing it to 10 inches per minute feed rate, 10 inches per minute plunge rate. Here you see the 3D telling you which it is. 55 is the order, finish, 0.125, 50% overlap, and a 0.0125 calculated. Here you see the projected toolpath, and in the preview you notice that I have lined the bit only to travel in the X direction, assuming that that's the direction of the wood grain. By doing this, you'll end up with a nice looking carving that has very few of the hair-like splinters that stick up on it. I've noticed if you cross the grain with your bit, you generate hundreds of these little hairs that stick up. So I've got it in the habit to make the bit travel in the direction of the wood grain. You notice with a 1/8 bit with a 15% overlap, you end up with a fairly smooth carving. Now right around the edge of the circles you can see the individual tool lines. If we did a circle type carving, they would be gone, but you'd end up with hairs just about on every edge. So it's kind of a give and take. It is possible to run another tool path where it does a circular tool path around the edges of the circle. You would end up with a much smoother cut. You wouldn't see the individual tool path. But the truth of the matter is, it is so small that you'd have to get right up on top of it in order to see it. So I don't think it's worth the time it takes to carve. But if that's something that is important, we could generate another tool path to deal with that. Basically this design is in a bowl, It's designed to carve. I tried to design it so that the top edge of the 3D image is very close to the surface of the uncut board. Now, if you look down here where my mouse is, when I run over the 3D image, you'll see the Z coordinates. See right here, it looks like 0.006 deep, which is very shallow. The edge of the bowl is a little over a 1/16 of an inch deep, which I consider to be acceptable. It's kind of nice to lose some wood off the top of your 3D image in case the rough board is not quite level. If you take off a 1/16 of an inch or so, you'll end up with fresh wood, newly cut, so it has a consistent look. So I hope you like this. Give me feedback and let me know what you think about the design. So this is the 3D image carved in a bowl. Thank you very much for watching. Give me a phone call if you have questions about what we can do for you. This is Lee Noring. My phone number is area code 916-672-1132. Thank you for watching. Bye for now.